we're going to look at chapter 7. This is the second law in the Carnot cycle, and now we're going to begin to examine the quality of energy, its value to us. So the second law relates to the value of energy. How useful it is to us. So for instance, if you want to stay warm, 1,000 kilojoules of energy at 35 degrees C is more valuable to keep us warm than 1,000 kilojoules at 5 degrees C, which is cold. And so this energy at 35 is more valuable than this energy. And we begin to explore the value of energy and what happens when we have an energy transformation that occurs. We know energy is conserved. We're going to see that the value of energy is not conserved. And that's what we're interested in. So there's a way to write this second law, and with the first law, whenever there's an energy transfer process, when energy is transferred, the total energy is conserved. You know that this is a conservation of energy that we've been dealing with all along. But the value cannot be conserved and some energy must be permanently reduced to a lower value. I think I should start writing higher on the board because I dislike writing lower, as most people know. So now, let's look at two blocks. So we'll take two blocks. Block 1, block 2. And we'll say this block's at 500 degrees K. This block is at 1,000 degrees K. And we can say that the internal energy U1 is equal to M1 CT1. So the mass, the specific heat, and the temperature U2 is equal to M2 CT2. We'll let them be the same material, so they're the same material, same pieces of copper, metal, whatever. And now we're going to stick them together. So we stick them together. Let me erase what I wrote here. And we know what's going to happen when we put them together. Heat's going to flow from the higher temperature to the lower temperature, and they'll reach some equilibrium temperature. So we can write that, this final temperature U3, where M3 is equal to M1 plus M2. So I know that U3 is equal to U1 plus U2, and I can write this out that M1 plus M2 times CT3 is equal to M1 CT1 plus M2 CT2. Now, if I let the masses be equal simply to make life easier, so if I let M1 equal M2, then we'll see this is a 2m, so I have, and the c's cancel, so I'm going to cancel out the c's. And this is 2m T3 is equal to m T1 plus m T2, or that T3 is equal to T1 plus T2 over 2. So it's 1500 over 2 is equal to 750 degrees Kelvin. So when we look at the second law, energy was conserved. So this was the energy is conserved. The value of energy, some must be reduced to a lower value. And the value of energy is associated with temperature. We will learn in chapter 9 it's associated with other things, but it's associated with temperature. Just as in the very beginning, the 1,000 kilojoules of heat was more valuable at 35 than it was at 5. So now, energy at the highest value, some has been permanently reduced. We can never get back to 1,000. And that's what the second law is telling us.